Okay, now we're going to go over an example of number 41 in the book. In that example, we're trying to find the limit as x goes to 2 of x squared minus 3. We could take a guess at this with direct substitution, where we put 2 into here, right? And 2 squared is 4, and then we subtract off 3. We make a guess that our limit would be 1. They give us a height to try and find an associated width for. That height is 0.01. So what we have to do is find a width such that if any x value within the width of the box from the point 2 or the value 2 is less than what we say it is, it will imply that, and this little arrow here means implies that, the value of our function f of x will remain within the height of the box from centered at 2, 1. And the height of our box given arbitrarily by the problem in the book is 0.01. So if we look at the picture in general, right, what they're saying is find for something that's really tiny above, right, well, 0.01 relatively speaking probably isn't that tiny, but tinier than what we've seen in class so far. Find a width of the box such that each function remains within it. So we don't know what it is yet. We don't know what the width should be. But we could take maybe a guess, right? So I can say from 1, let's add 0.01, and we get 1.01. And from 1, let's subtract 0.01, and we get 0.99. So I can try to find a value of the function for that's equal to 1.01. When I solve this, right, so I have x squared minus 3 equals 1.01. My x squared value then would be 4.01. And when I take the square root of this, right, I get 2.002498, etc., etc., etc. When I take x squared minus 3 equals 0.99, and I do the same thing, I get this. I take a guess that it's probably going to be the positive square root, right? Because that's closer to my limit point, right? It's probably not going to be this negative square root because that's not as close to my limit point. I'm just kind of I'm not using a vigorous method to do this. I'm trying to get an intuitive feel. So I can make a guess that my delta is maybe probably close to around maybe 0.002. Looking at my two x values here. So I make that guess, right? So I go 2.002 to the right and 1.998 to the left, and I let that be the width of my box. At this point, I don't actually know that the rest of the function falls neatly within that, right? Maybe I could do something like check it and see whether or not this holds if I put maybe my endpoints into there. So let's say I try out 2.002 squared minus 4. When I put that into the calculator, I get 0.008004. And this, so far, is less than 0.01. So the right end of my box seems to work. How about the left end of my box? I get 1.998 squared minus 4. And, by the way, we have to take the absolute value of these things, right? and I get negative 0.007996. This is greater than negative 0.01. Another way to write this is, if I take the absolute value sign of this quantity, then that would be less than 0.001, or excuse me, 0.01. So far my guess is looking okay, but I don't know for a fact that 0.002 would work for every value of the function in between. Maybe I have to look at it using a little bit of algebra. So I make a little bit of a check, right? And my check will be that I'll rewrite this inequality, or this absolute value function of, or absolute value of x squared minus 4. And I'll factor the x squared minus 4 into two different quantities of x plus 2 and x minus 2, and take the absolute value of that. Now there's a property of absolute values such that if I have two numbers multiplied together inside of an absolute value, here x and y are actually arbitrary. They could be a and b, just so that I don't mix up some symbols. This will always be less than or equal to the absolute value of a times the absolute value of b. So, knowing that, I can split these up into two different absolute value functions, right? So, this quantity will always be less than x plus 2, and this will be less than the absolute value of x minus 2. Now, if delta is what I set it to be, of 0.002, then I know that this x, the absolute value of x minus 2, is going to be less than 0.002. So I can say that this whole thing will be less than, replacing absolute value of x minus 2 with 0.002, I know that this will be less than what I have written here. Because I make that assumption, I have control over it. That's part of my assumptions, that the width of my box is less than that delta, and I chose that delta. I chose that delta to be 0.002. But what about this quantity right here, the absolute value of x plus 2? Well, if my delta is 0.002, I know that any x value that I have has to be within the interval of 1.998 and 2.002. So the maximum value, just by inspection that I can see, would have to be 4.002. That's the largest that this could possibly be. I take the largest number that I can get out of this, which would occur when I put 2.002 into it. 2.002 plus 2 is 4.002. And that would be the biggest that this could possibly be. So then this, what I'm trying to look at, would have to be less than, again, absolute value of x plus 2 times 0.002. And since this is less than 4.002, I can bound that, right? Then when I multiply these two values together, I get this. And 0.008004 is less than 0.01, the height that I was trying to get my box to be within. So now, without just checking the endpoints, I know that for any value of x within this interval, I'm guaranteed to have a height of every value of my function to be less than that given height that was just shown. In the next video, we'll try to look at this in the general sense. Instead of just for one value of epsilon equal to 0.01, we'll look at any arbitrary value of epsilon.